Welcome back to Energy Explained, our family YouTube channel. I am joined with me today with my father from outside Raleigh, North Carolina, and he comes to us courtesy of Stanford Engineering and the PhD program sometime in the 70s, let's say, and also the former C2 of Halliburton in a more recent vintage, and now consults for energy companies worldwide. Certainly a matter of authority on all things energy. I am joining here from Amsterdam and just form the host. Today we have an amazing topic, which really is truly ripped from the headlines, and this is one of the things I love about doing the show with you, Dad, is that I learned so much as part of it with the briefs you put together. And what we're going to talk about today is recent announcements from ExxonMobil and a related announcement from BP around a new business model where they're going to take CO2 from the Houston Ship Channel and store it underground and capture that CO2 and take it out of the atmosphere and take it out of the warming process, and using that technology as a form of mitigation of greenhouse gas. Now, I want to just start with, what are we talking about here in terms of the core technology?
Yeah, so the core technology, as you call it, is well, you begin with capturing. Somehow you capture it and you bring the CO2 to the wellhead. Then you drill a well, and the technology involves putting the CO2 into one of two reservoirs, I'll call them. One is what's called a depleted reservoir, which is that some place which had already produced hydrocarbons and now is devoid of fluid. And so now you can put new fluid in. The other is something called saline aquifers, which you can put CO2 into, which is basically salt water, rock containing salt water.
Yeah.
It's more the depleted reservoir is the more common one, and basically you just pump it in, and the thinking is that it will stay put because the original fluids from the hydrocarbon production did stay put for millions of years. So if you put new fluid in, it's probably going to stay put. So that's the idea, that it'll just be put in there and it'll stay there.
Okay, but how is it? Okay, how are we capturing the CO2 to begin with?
Right. So there are two types of CO2 capture. One is something called point sourced capture. Sorry about the jargon, and that is a smokestack or something. It's basically the output of an industrial process. That's the point source. So the output of a cement plant or of a steel plant or whatever. The other one, which is more recent and quite separate, is something called direct air capture. So this is where doesn't matter how you produced it, it's in the air and you catch it from the air. That is relatively new. These are the two methods.
So in terms of the technology, I hear that one part is, what do you do with it? And you've talked in other episodes about mineralification. You turn CO2 effectively into a rock. Simplifying matters, bury the rock. We know you've explained that in the past. Now, here we're talking about a different method where we're essentially capturing from the air and pumping it way, way underground in a place that it seems like it can sit in a stable space. Now, just simplify it for me, what are we pumping down there? Is it a liquid that the CO2 is trapped in, like almost like carbonated water that you get from your Sprite machine? Is that what we're talking about here?
Yeah, actually, it's a little more tricky than that, as it turns out. We put in what's called supercritical CO2. So supercritical means it's a weird ass state, which is it behaves like both a gas and a liquid. Okay, and the cool part about that is that it'll enter the rock as if it's a gas, easily enter the rock, and then will react as you want as a liquid. And that is achieved at around 31 degrees C and about 1,000 psi. So not much. So some pressure, not much temperature, and then you put it down. So it's kind of, you might call it a liquid. Yeah. Mm-hmm.
Yeah, I've heard of, I think if our viewers want to look at YouTube videos, I've heard of supercritical water, where you have water absolutely pure water, cooled below freezing point, will stay as a liquid if there's nothing to nucleate on. And then you can stick a pencil in the water bottle and it will just freeze instantly. And I advise people to check it out. So it sounds like it's a state of matter that can be carefully curated and then is amenable to instant fixation. That's super interesting. But let me ask you this, talking about that free to air capture. Growing up, I think I was part of that generation where that technological optimism still was permeating society. Now we see movies that are much darker about the future, but there was this sense of like the Jetsons of like, we'll just figure it out. When you hear free to air capture, you're sort of thinking, is this going to solve everything? Do we need to stop being environmentally sound? What do you think about when you sort of think about this tension between technology solving everything versus not being too pessimistic about potentially very viable futuristic technologies like capturing carbon out of the air, supercritical liquefying it, putting it on the ground? It sounds magical to me. How do you balance that in terms of your outlook?
Yeah, well, that is one of the big criticisms of that form of carbon mitigation, which is catch it and put it away. The criticism is exactly what you're implying, which is then it sort of gives you a free ride. Go on doing what you're doing because technology will solve it for you. They will catch it and put it in the ground or do something else with it. So that is one of the criticisms, that it gives a free pass for business as usual in all forms of industry. So the alternative to that is doing it differently. So whatever process you have, that you do it in such a way that you do not emit CO2 in the first place. And obviously, if you can do that,
Right.
then it's the right thing to do. It's better to do that. But many processes either cannot or cannot easily do that. And so right now, I would say that we should address this issue by doing both. That whenever possible, we would change the process. For example, electric vehicles changes the process. You Instead of internal combustion engine, you've got electric drive, so there's no tailpipe emissions. Mind you, there are emissions at the power plant, but point source emissions are easier to catch than distributed.
Right.
So catching CO2 at tailpipe, it can be done, but it is very tricky. Whereas catching it at a plant is much easier.
So we have the geologic sequestration piece. This is the piece that in some sense is what the story is about. Dig a big hole, simplifying greatly, take a uniquely situated version of CO2, super cooled liquid, something super fluid, and pump it into rock. And it will then bind itself geologically for millennia, hopefully. That piece is new. And what you've explained to us is that piece costs $3 to $5. Now, we know from what you've explained to us earlier, the going price of carbon for a ton is $55. So that 5 versus 55, 10% of the cost doesn't seem too prohibitive to me. But is that a price? Is that a market competitive price for the sequestration part right now?
Yeah, but don't forget, it cost you 40 plus to actually catch it in the first place.
Right.
The 3 to 5 is just to actually insert it into the ground. So the total is about 45. And yeah, it's market competitive in the sense that there aren't too many ways that we know of right now to catch and put away CO2 for under the current market price. So yes, it's market competitive. But then the question is, in the long haul, is that the direction one should go? And my answer is not if other alternatives are available. I would prefer to do other alternatives other than that sort of geologic sequestration. And
now let's talk about
details,
that
but
price.
that's my preference. Right
and
now.
You said, hey, the capture part, and you've talked about point source capture as being the most economical today. So what you believe is true is that at present, point source capture combined with the sequestration technologies available, this being one of them, will become ultimately economical at a carbon tax of, say, $55 per metric ton. Now, if the government wanted to If we wanted to have more aggressive climate goals and that tax goes up, obviously more technologies become viable. But this is interesting because it seems to be beating the classic ones of planting trees and stuff, which we know is finite in nature. There's only so much of this can be done. Do you see these technologies as a fundamental step forward in our ability to mitigate greenhouse gas capture combined with geologic sequestration or other sequestration techniques? Do you see that as a genuine step forward or not?
Yeah, no, I think it is. I think that point source capture has really reached what I would call a tipping point. Uh, I've observed that technology carefully, and I believe it's to the point where it's scalable and at those kind of numbers. Not quite there. I mean, say within the next 2 years. So I think that so in one sense, what the oil companies announced is the right direction, which is to find the sinks, as I call them. Uh, that the sourcing may be on its way, well in hand, so to speak, but sinking, putting it away, is where the emphasis should be. And they've provided one such right now. So it's in the right direction.
Okay. But this free to air capture, this is more speculative because I mean, you told me in the show notes that the issue here is the density of what you capture is not high, and therefore the sequestration is more challenging. Do you see this geologic sequestration as really viable for free to air capture at present, or is that more part of the speculative hype of the whole announcement?
No, direct air capture is kind of gee whiz right now because you can do it anywhere. That's the good thing about direct air capture is you can do it wherever the sink is. So you essentially eliminate transportation of the CO2. So you don't have to co-locate the source in the sink. So that's what's neat about direct air capture. What's difficult about it is there are two methods right now. One is, well, I'll tell it to you. One is to adsorb it onto a solid substance called adsorption, and then later release it by increasing the temperature. It's called, and then the other one is to absorb it into a liquid and then release it later. Both those methods, while technically feasible at this time, are very costly. They are well over $100 a metric ton of CO2. So it's got some ways to go to get to be economical. And it got the biggest pushback from certain environmentalists because it seems to be more of a free pass to do what you're doing because we can catch it anywhere. But yeah, it's further behind in technology, in economics. The actual science of it is pretty straightforward. But it's further behind in the sense that I give you the number of 40 out there. This guy is well over 100. I mean, nobody. There's one company claiming to be between 85 and 235. Well, geez, that's quite a spread. But at any rate, I would say it's over 100.
So, interesting overall picture here is your view is that we have more advanced technologies in capture at point source. The issue has been where to put the CO2. And these developments are real material and potential step forwards in the sink or the sequestration aspect of it. But the free to air stuff is more speculative if we can ever capture it that efficiencies and has more issues involved with will that discourage a responsible energy use and other aspects, given the current economics of capturing it is really not there. So it seems like a pretty clear picture that there is a lot of realness here, but it's not the solution. It's part of a more complete solution. Really interesting that this is being led by these major energy companies, a consistent theme we're seeing of energy companies being at the forefront of some of these solutions. With that summary, anything that I missed? Any last words?
The only last words would be that all that said, we really need to put a good foot forward on alternative processes, on making steel a different way that doesn't produce CO2 in the first place. But capturing it and putting it away will sort of hold the fort for a while. But in the end, I believe...
Very clear. And in terms of our video on hydrogen economy, that's when we talk about a fundamentally new way of powering energy needs with hydrogen instead of hydrocarbons. That ultimately is more transformative. This cleanup solution will be part of it. You've talked about how natural gas is part of the transition. This sounds like it's part of the transition, but I'm hearing you very clearly. These should be viewed as transitional technologies, not core problem-solving technologies, because there are ways to produce energy without hydrocarbons, and that has to be where we ultimately go, not rely on our ability to clean it up. Very clear. Thanks for your time today. We have been at this is, I think, our 10th episode. Been super fun all the way through. We ask you, if you liked it, hit subscribe. If you're on a podcast platform, hit follow. If you have some episode requests or ideas, throw them in the comments. We look at those. We really appreciate all the support. And with that, we'll sign off. Thank you.